Hello, this is Abhijit Kale. In previous video, we learned view. Now in this session, we have to learn materialized view. Learning a materialized view. What is materialized view? So, as we know, materialized view is a logical structure. In other hand, materialized view is a physical structure. We can judge by using row ID. When we create a materialized view from a base table, that time the row ID will be different. Means it's a physical. Means the row ID of a base table as well as the row ID of a materialized view is different. So it's a physical structure. Means that means it has own structure. It has own structure. I'm going to write now. Materialized view can have physical structure while normal view have logical structure. We can judge by row ID. It is used to store highly secure data. It is a database object. It is a database object that contains the result of query. The main thing is that we can't perform DML operation on materialized view. Sorry. It is used for data analysis. And reporting purpose. It is mainly created to overcome the performance issue and store historic data. Overcome the performance issue and store historic data. It is used in data warehouse. Use of MView are join between tables. Aggregation on a single table. And third one is aggregation and join together. Means need of motive. Why we materialized view are created? Means need for materialized views. We can use MView to increase the speed of queries on a very large databases. Queries to large databases often involves join between tables, aggregation such as sum. These operations are expensive in terms of time and processing power. The type of MView we create determine how the MView is refreshed and used by query rewrite. It can improve the performance by recalculating an expensive join and aggregation operations on the database prior to execution, storing the result in a database. Now we can create a materialized view, normal materialized view. Here in this system have already the name of same name materialized view. Now we can update it, change it. The materialized view is created. Up to 10G in the base table there are mandatory of a primary key in a table. Means if the base table doesn't have a primary constraints, that time the materialized view are not created. Now we can check it. Select start from here. We now select start from materialized view. Here are 15 records and here also 15 records. But now when we perform a DML operation on materialized view, it doesn't operate. It getting an error. Data manipulation operation does not legal on this view. On other hand, we can perform DML operation on base table. That time it doesn't directly affect on the materialized view. We have to refresh it. Update emp where ename equal to abhijit. Update emp set ename equal to abhijit where ename equal to smith. Now we can see in emp table, in base table, smith have updated by abhijit. And in mview materialized view, it doesn't affect directly affect on the materialized view. Means we have previously seen that in a view, when we can update, we can perform DML operation on table, that time it doesn't it directly affect on the view and vice versa. But in materialized view, when we perform DML operation on a table, that time it doesn't directly affect on the materialized view. We have to refresh it using exec command. Exec dbms dot mview exec dbms underscore mview dot refresh in bracket in parenthesis in string caps of materialized view name. It's a procedure. Randomness block completed. Now we are going to check materialized view. It is affected. It's a complete refresh. Now we can also change it. Now we can check the row IDs. It will be changed or not. Select row ID e dot star from UPE. This row ID is for employee number 7369. Seven five six six. And now we'll check for select row ID comma m dot star from materialized view. This row ID is for employee number 7369. Here we can check that the row ID will be different from a base table and materialized view. So we have checked by row ID, means it has a physical existence. It has own structure. Now we are going to update emp set name equal to Abhijit, where name equal to Smith. One row is updated. Now we can check. In base table, the row ID is same. Now we can check in materialized view. In materialized view, the row ID is also same. Materialized view have two types. Then we have to move on types of view. Means it have two refreshing methods actually. Fast refreshing method and complete refreshing method. refreshing materialized view. First is complete refresh. Second is fast refresh. Fast refresh. By default, MView is a complete refresh. And when we create materialized view, materialized view name, refresh complete. That's select star from EMP. Here materialized view is created. Now we are going to check row IDs. For employee number 7369, the row IDs. Then for 7566, 66, the row ID is this one. Now we are going to check the row IDs for materialized view. For employee number 7369, 7566. Now we are going to update on base table. Update TMP set name equals to Abhijit. Where name equals to Smith. One row is updated. Now we are going to check in base table the row ID is same. And now in materialized view, after refreshing we can check it. Now we are going to check it. It is updated. The row ID is different. Also check for another employee number. Here it is also different row ID. Means in when we create a materialized view using complete refresh, that time the row ID will be recreates. So it automatically degrade the performance of database. Now we are going for fast refresh. Materialized view. Create materialized view. Materialized view name. Refresh fast ads. Select star from EMP. Materialized view is created, but before materialized view, refresh materialized view using refresh fast method, creating materialized view log. But in this system I have already created a materialized view log. See, that's why I directly created fast refresh materialized view. But if we don't create a materialized view log on base table, that time fast refresh materialized view does not created. Now we can update DML, perform a DML operation on a base table. Update EMP, set ename equal to Abhijit. Where ename equal to Smith. One row is updated. Now we are going to refreshing it. Sorry, but before that we are going for check the row IDs. For employee number 7369, the row IDs. For employee number 7566, now we are going to check the row ID for materialized view. For employee number 7369, the row ID is, it's different from base table. That's why it has physical existence. Now we are going to update. Let's perform DML operation on a base table. Update EMP set ename equals to Smith. Already Smith. Set ename equal to Abhijit, where ename equal to Smith. One row is updated. Now we can refresh it. Now we are going to check the row IDs from base table. It's the same. It is also same. Now in fast refresh, it is also same. And in this employee number for the row ID is also same. Means when we create a fast refresh materialized view, that time the row ID doesn't recreate, fetching from materialized view log. That's why it have increased the performance of database. This is the fast refresh method for creating a materialized view. There are also automatically refresh the materialized view by using on demand and on commit. On demand and on commit means it automatically refresh materialized view. Automatically refresh materialized view. Create materialized view adds refresh on commit. Refresh on commit adds select star from emp. Your materialized view is created. It refresh on commit. Means generally we are refreshing materialized view either manually or automatically. In manual method we are using dbms underscore mv package. This is a package. This method is also called as on demand method. By default method is on demand. From we can retrieve materialized view information using select star from user underscore mviews or select star from all underscore mviews or select star from tba underscore mviews. This is a dba command. This is about the materialized view. So in this session we are going to we was discussed on materialized view. In next session we are discuss on constraint and types of constraint. That's all. Thank you. Thank you.